Researchers at Lawrence Livermore are working on better understanding the effects of earthquakes, which includes simulating what might happen during one. This simulation shows a magnitude 7.0 earthquake on the Hayward Fault, and the area shown in this animation covers most of the populated San Francisco Bay Area. This is the highest resolution earthquake simulation ever done for Northern California that takes into account three-dimensional geological structure and topography. To achieve this level of detail, the simulation was done on one of the lab's supercomputers, where the calculation ran on over 86,000 processors for 18 hours. Let's take a look at what happens. The earthquake starts at the northern end of the fault. A 50-kilometer section of the fault ruptures, shown as the black line. The intensity of ground shaking is shown according to the color scale on the right, where red indicates the strongest shaking of up to 1 meter per second, shaking that can damage buildings. The blue color indicates shaking that could be felt but not cause damage. The earthquake only takes about 20 seconds to rupture, but the seismic waves traveling away from the fault shake the entire Bay Area for over 90 seconds. The intensity of ground shaking varies from area to area according to the pattern of slip on the fault itself and the geologic structure of the ground. For example, low seismic wave speeds of softer sedimentary rocks amplify shaking compared to harder rocks. That means that sedimentary basins like the San Pablo Bay, San Leandro Basin, Santa Clara Valley, Dublin-Pleasanton-Livermore Valley, and the Delta experience longer durations of shaking because their geologic structure can trap seismic waves. Simulating ground motions during and after an earthquake, like in this animation, can help us evaluate seismic hazards and calculate potential damage to buildings. The particular scenario represented in this simulation is just one possible rupture of the Hayward Fault. Future simulations will explore other possibilities and will continue to help us prepare for earthquakes and their consequences.